Hello everyone, welcome back to another video. In the previous video, we learned about expanding binomial products, and in this video we will be talking about perfect squares and what they are. By the end of it, you should be able to identify what a perfect square is, you should be able to expand a perfect square, and you should be able to expand to form a difference of perfect squares. So not only will we be able to identify what a perfect square is, but we will also be able to calculate the expansion of perfect squares, such as a plus b whole square or a minus b whole square, etc. Now let's start with what a perfect square is. Well, a perfect square is the result of any integer multiplied by itself. For example, we have 4. Now, 4 is a perfect square because it has an integer that can multiply by itself to amount to that number. So 2 multiplied by 2 gives us 4, right? Well, that shows that 4 is a perfect square, since 2 is an integer that when multiplied by itself can give us 4. 36 is also a perfect square because you can have an integer that when multiplied by itself amounts to 36. For those who don't know already, integer is just a fancy word for number. So 6 times 6 can equal 36. Here we have 6 being the integer that when multiplied by itself gives us 36. Something that is not a perfect square, however, is 30, because there is no integer that when multiplied by itself that could possibly give us 30. 5 times 5 equals 25. 6 times 6 equals 36. There is nothing in between. The closest way to get to the same integer would be 5 multiplied by 6, which equals 30. But even then, 5 and 6 are not the same integer. Therefore, it is not a perfect square. Now that we have established what a perfect square is, which is essentially the result of any integer multiplied by itself, let's figure out how to expand a perfect square. And by expanding a perfect square, I mean specifically, how do we calculate a plus b whole squared? Now, we are given the question here, a plus b whole square. How do we expand that? Well, you would expand something like 2 squared by doing 2 multiplied by 2, correct? Now, you simply apply the same sort of logic with a plus b whole squared, which is simply multiplying a plus b by a plus b. Therefore, you have a plus b multiplied by a plus b. Now, for those who aren't familiar with multiplying binomial products, you use something called the distributive law. And you use the distributive law by taking the first integer of the first number in the first bracket and multiplying that with the other integers in the second bracket. So we would do a multiplied by a plus a multiplied by b, and then you add that with b multiplied by a and b multiplied by b. So if we do that here, a multiplied by a equals a squared, and then a multiplied by b equals ab, and then you add that with b multiplied by a, which equals ba, and b multiplied by b, which is b squared. And obviously ab and ba is the same thing, since it's just the reversal of order when it comes to multiplication. Now, if we try and evaluate that, we realize that you can add ab and ba, which equals 2ab. So our final answer becomes a squared plus 2ab plus b squared. So it's as simple as that. Whenever you want to calculate how to expand a perfect square, you simply multiply the perfect square by itself, and if needed, you use the distributive law as shown here. Let's try an example. So we have here x plus 1 whole squared. Well, again, to find the perfect square of something, you multiply an integer by itself. So x plus 1 times x plus 1. And once again, you use the distributive law and multiply x with x, and then multiply with x with 1, and then do the same thing for this integer here as well. 1 multiplied by x and 1 multiplied by 1. And then here we start multiplying 1 by 1. So x times x, that equals x squared. X multiplied by 1, that's just 1x, or x. And then we have 1 times x, which equals 1x or x, and 1 times 1, which is just 1. And now, if we evaluate it once again, our total answer will become x squared plus 2x plus 1. So for anything regarding the lineage of a plus b whole square, you just need to remember that a plus b whole square will always equal a squared plus 2ab plus b squared. So you just substitute that sort of formula into any question relating to that. Now let's try a quicker way instead of using the distributive law. Now we have x plus 3 whole squared. Now we can use a plus b whole squared. We can use the same sort of logic. Let's make a equals x and b equals 3. So if we want to use this a squared plus 2ab plus b squared, we substitute x and 3 into it. So a squared would become x squared, 2ab would just become 2 multiplied by 3 multiplied by x, since b in this situation is 3 and a in this situation is x. So that would be 6x, or rather be 2 multiplied by 3 multiplied by x, which amounts to 6x, but we will evaluate it later on. And then b squared, so if b is equal to 3 in this situation, then 3 squared just equals 9. Now if we put it all together, it will simply equal x squared plus 6x plus 9. Okay. So just keep that formula in mind. A plus b whole squared equals a squared plus 2ab plus b squared. Keep that jotted down in your memory, and at desperate times when you fail to remember it, just think about it logically, think about it calmly, realize that you multiply an integer by itself to get it to a perfect square, therefore you would do the same with any other number, and then use the distributive law if needed. Now, let's calculate a minus b whole squared. Well, again, using the same logic of multiplying an integer by itself in order to get a perfect square, we would simply do a minus b times a minus b, because that's what would get us a minus b whole squared. And the way we do that is by, once again, applying the distributive law. We multiply a with a, and multiply a with minus b, and then we add that with minus b times a, and minus b times b. Now, if we try and evaluate it, a multiplied by a is just a squared, a multiplied by negative b equals negative ab, and then negative b multiplied by a equals negative ab, and b multiplied by negative b equals b squared. Evaluating it, it equals a squared minus 2ab plus b squared. Let's look at some examples. So x minus 5 whole squared. Pause the video if you need to take some time in order to solve the question. Now, let's think about this logically. To get a perfect square, you multiply an integer by itself. Now here, the integer is x minus 5. So what we have to do is multiply x minus 5 by itself, which is x minus 5 multiplied by x minus 5. And to do this, we use the distributive law and multiply x with x and negative 5 with, x with x, then x with negative 5, and then negative 5 multiplied by x, and negative 5 multiplied by negative 5. Now, doing so, we evaluate it. X times x just equals x squared, x times negative 5 equals negative 5x, negative 5x times, negative 5 times x equals negative 5x, and negative 5 multiplied by negative 5 equals positive 25. Evaluating it, it equals x squared minus 10x plus 25. Now, if you noticed a pattern already, feel free to pause the video if you haven't and try to find the pattern. But if you have noticed it, then you will realize that a minus b whole squared actually equals a squared minus 2ab minus, plus b squared. This will turn out the same for every single question when it is in this format. So if you want to do something quickly, just be sure to use this formula instead of using the distributive law. Let's try a minus b whole square. Let's try that formula for this question. X minus 7 whole squared. Here we can substitute a becoming x and b becoming 7. So that would equal, so if we do a squared would equal x squared. Sorry, I'll do it somewhere else. Sorry, a equals x, b equals 7. So a squared would become x squared minus 2ab, so 2 multiplied by x multiplied by 7. So 2 multiplied by 7 multiplied by x plus b squared, so 7 squared, which equals 49. Evaluating that, we get x squared minus 14x plus 49. So always keep that in mind for expanding a minus b whole square. And so these are the two formulas you essentially need to keep in mind. A plus b whole square, this is the formula, and then a minus b whole square. Be sure to take a screenshot if you haven't already. Now, let me introduce you to something which is called performing DOPS. DOPS means difference of perfect squares. How would you perform the difference of perfect squares? Well, such questions could come up such as this one, a plus b times a minus b. These are the difference of two possible squares, and what you do is simply evaluate it. Now, we use the distributive law, and we find that a multiplied by a times a multiplied by negative b, and then we do the same for b multiplied by a times b multiplied by negative b. Now, when we evaluate it, a multiplied by a equals a squared, a multiplied by negative b equals negative ab, b multiplied by a equals ba, and b multiplied by negative b equals negative b squared. And when you evaluate it, you realize that there is a negative ab and a negative ba, so that cancels out. So eventually, all that remains is a squared minus b squared. Let's try it again with another example. So x plus 7 times x minus 7. We use the distributive law. We multiply x with x, and then you do x multiplied by x minus 7. Sorry, I should show it again. X multiplied by x, and then x multiplied by negative 7. And then you add that with 7 multiplied by x and 7 multiplied by negative 7. Now let's evaluate it. X multiplied by x equals x squared. X multiplied by negative 7 equals negative 7x. Then you add that with 7 multiplied by x, which is 7x. 7 multiplied by negative 7, which equals negative 49. Once again, the two middle objects cancel out, so it just remains x squared minus 49. Now there's another pattern. If you haven't figured it out, feel free to pause the video. Now, one thing you notice about a plus b times a minus b is that no matter what, it will always amount to a squared minus b squared, and vice versa. So let's just keep those jotted down. So feel free to take a screenshot of these formulas because these are very helpful and would save you a lot of time. Now let's try substituting using the newly learned formula given. We have x plus 9 times x minus 9. So in this case we can use this formula. So a would equal x and b would equal 9. So if we do x plus 9 times x minus 9, we know that a plus b times a minus b equals a squared minus b squared. Therefore, x plus 9 times x minus 9 would just equal x squared minus 9 squared. So this would therefore equal x squared minus 9 squared, which equals 81. X squared minus 9 squared, and 9 squared is just 81. So that's our answer. Now, let's try some spare questions to solve. x plus 5 whole squared. Pause the video to try and figure it out before we go ahead and discuss it. Now, there's two ways to do this. Obviously, we can try substituting a plus b whole squared, that formula, and we find a equals x and b equals 5. Therefore, a squared plus 2ab plus b squared. If we substitute it, a squared would just be x squared. 2ab would be 2 multiplied by 5 multiplied by x, and then b squared would just be 5 squared. And then that equals x squared plus 10x plus 25. Or you can do it the long distributive law way, and that would be simply x plus 5, x minus 5, and then x multiplied by x multiplied by negative 5, 5 multiplied by x, and 5 multiplied by negative 5, and then we make that into x times x plus 5 times plus 5 times, sorry, should be x minus 5 here, and then we have 5 times x minus 5, and when you evaluate it, that equals x squared, x times negative 5 equals negative 5x. Here we have positive 5x. Oh, sorry, I'm making a mistake. Oh, Lord. X plus 5 squared should equal x plus 5 times x plus 5. Silly me. Shouldn't be x plus 5 times x minus 5. Anyway, so x times x plus 5 times x minus 5, and that would just equal x squared plus 5x plus 5x plus 25, which equals x squared plus 10x plus 25. Let's try another one. 5 minus x squared. Now, we could use the distributive law, but I think we're all practiced it and skilled enough to try and use the quicker method, and that would just be using the a minus b whole squared formula. So this would be a minus b whole squared, which we all know already equals to a squared minus 2ab plus b squared. Now, a equals 5 and b equals x. So if we substitute it, it would just be 5 squared minus 2 multiplied by 5 multiplied by x plus x squared. And that just equals 25 minus 10x plus x squared, which we can obviously rearrange to x squared minus 10x plus 25, but it really does not matter. And now we have one final question, which is for performing DOPs, and that is x plus 11 times x minus 11. Now here we have the essential a plus b times a minus b situation, and we know that that equals a squared minus b squared at all times. Now if we substitute it, a equals x, b equals 11, so x squared minus 11 squared, which is just x squared minus 121. Let's try and do some more worded problems. A square piece of tin of side length 20 centimeters has 4 squares of side length x centimeter removed from each corner. The sides are folded up to form a tray. The center square forms the tray base. Write an expression for the side length of the base of the tray. So the base of the tray is just this little square here, and this is just x. These are both mounted to x, and the entire thing is 20. Now, since the tray base is essentially the length of this minus this and this, we can say that it equals to 20 minus 2x, because that is the side length that's being taken away from each side. So the side length would be 20 minus 2x, and the next question is write an expression for the area of the base of the tray. Now, since it is a square piece, we know that it would just be 20 times 2x, 20 minus 2x multiplied by 20 minus 2x, and that's just a minus b whole squared, and that would equal to a squared minus 2ab plus b squared. A equals to 20, b equals to 2x, so it would just be 20 squared minus 2 multiplied by 20 multiplied by 2x, plus b squared, which just equals to 4x squared. Now when you put it all together, it would just be 20 squared minus 80x, I think, yeah, 80x plus 4x squared. Find the area of the tray base if x equals to 3. Now, all we do for that would just be substituting x equals to 3 into this equation. So that would just be, I'll just write all this part off because it's unnecessary now. I'll write the answer down here. 20 squared, I could just rearrange it actually. 4x squared minus 80x plus 20 squared, which is 400. Now we substitute x into this, so x equals 3. 4 multiplied by 3 squared minus 8 multiplied by 3 plus 400. And that would just equal 36 minus 24 plus 400. And when you calculate that, that's just equaling to 412. 412. Find the volume of the tray if x equals to 3. Well, sorry, apologies. The volume of the tray would simply be x plus x minus 3 times x minus 3 times x minus 3, since it's just length times width times base. However, that's trinomial products, which we haven't discussed and we'll cover another time in the video, so let's just ignore this question for now. Okay, let's have one last question and then we are done for today. 4 tennis courts are arranged as shown with a square storage area in the center. Each court area has the dimensions a multiplied by b. Find an expression for the side length of the total area. Well, the total side length would be this entire thing, and that would just be a plus b. So the expression has to be a plus b. Find an expression for the total area. The total area would be length times width, and if the length and the width is a plus b, then it would just be a plus b multiplied by a plus b. I think you can see where this is going. Write an expression for the side length of the inside storage area. Well, that would just be b, since the total side length is simply this much, and I think you can figure out that a is clearly the larger length of that one side, therefore it amounts to b. And write an expression for the area of the inside storage area. Well, if the side length is b, then it's just b squared. Oh, I should remember to mention that a plus b times a plus b is just a plus b whole squared. Now, subtract your answer to part D from your answer to part B to find the area of the 4 courts. Well, now they just want a plus b whole squared minus b squared. Now, you might be thinking we have to evaluate a plus b whole squared first, but if you try and look outside the box, you realize that this is as good as a minus b whole squared. Sorry, a squared minus b squared. So a plus b is equal to a squared. So we can amount a equals a plus b and b just equals b. There's no difference. And we know that a squared minus b squared equals a plus b times a minus b. So if a equals a plus b, then we just have a plus b, and then a plus b minus b. And that amounts to a plus 2b multiplied by a, just a. And we could evaluate that a bit more, which essentially just equals a squared plus 2ab. So there's your answer. Okay, I think that is enough for today. If you have gotten a better understanding, be sure to like, subscribe, and comment below what would you like us to work on. See you next time.